Hello students, after a gap of 2 days, I am taking the class now in the NEET 2019 series P2. Now I will take the question number from 11 to 20. And as I have told you earlier also, that you watch the video completely. It may be long, it may be approximate 1 hour, but if you want to learn that how to apply the formula and your application, then you have to watch the video completely. Also, you like, share and subscribe the video. So now question number 11. The average velocity of a particle executing SHM in one complete vibration in one complete vibration is. Now options. Number 1, A omega upon 2. Second, A omega. Third, A omega square upon 2. And fourth, 0. Now how to find the solution? You would find the average velocity. And we know that this average velocity is equal to displacement upon time. Now this is giving one complete vibration. In one complete vibration, the displacement is 0. So this is not 0 upon time t, so this is equal to 0. So the average velocity will be equal to 0. So here we come the right choice of this question is fourth, 0. This is not 0. Question number 12. A show ball of radius 1 mm of radius 1 mm is blown from a detergent detergent solution having a surface tension of 2.5 into 10 raised to the power minus 2 Newton per meter. Newton per meter. The pressure inside the bubble. Inside the bubble is equal to a point is equal to a point Z0 below the surface of water. Below the surface of water. Surface of water in a container. In a container. Taking G equal to 10 meter per second. Per second square. Density of water. Density of water equal to 10 raised to the power 3 kilogram per meter cube. The value of Z naught. The value of Z naught is now option. First 100 centimeter, second 10 centimeter, third 1 centimeter, fourth 0.5 centimeter. Now the solution. Now you are given a soap bubble. Soap bubble of radius 1 mm is blown from a detergent solution having a surface tension so much. This is the soap bubble. Its radius is 1 mm and it has the pressure P0. And P0 is equal to 2 this P0, and here we are given the surface of water. This is water. This is a point, and the distance of this point from this is equal to Z0. This is Z0. So what is given in the question? That pressure inside this bubble is equal to the pressure at a distance Z0 inside below the surface of this water in a container. So you have to find the value of Z0. So whatever the pressure is here, so this pressure is equal to 40 upon R. This we know. Here this is the pressure, suppose P, or this is now suppose pressure P dash, whatever is there. On both the cases the atmospheric pressure is also acting. So atmospheric pressure this acts on both, on this bubble and also at this point Z0. So what we have in equilibrium, according to question, what we have this P plus P dash equal to P plus P0, because this pressure will act here also and here also. So this P will cancel from both sides, and this P dash is equal to H dg equal to, this is now your 40 upon R. Now here this H equal to Z naught. So you take it to be Z naught. dg equal to 40 upon R. So this is giving you this Z naught equal to 40 upon R dg. So now you put the values that are given here in the question and then calculate the value of Z naught. Z naught equal to 4, T equal to 2.5, 10 is to the power minus 2, R the radius 1 mm, 10 to the power minus 2 meter, D 10 is to the power 3, G is equal to 10. So these two terms will cancel. From here this you take 10, this is now your 100, this 100 will cancel. So this is your 10 is to the power minus 2 meter. Then you convert it into centimeters. So this is your 0.1. Answer is given in what we take. This is your 1 centimeter, then this in convert this in centimeters, so this is now 1 centimeter. So our answer is what? This 1 centimeter, third answer. This is the right choice in this question. So just you have to equalize according to given condition in the question, that the pressure at this point P, at this height, at this depth Z naught equal to the pressure inside the bubble, and also you consider the atmospheric pressure. If you do not consider, even it make no difference because this will cancel from both sides. So we have to find the value of Z naught directly. Now question number 13. A copper rod of 88 centimeter 88 centimeter and an aluminum rod of unknown length having their increase in length independent of increase independent of increase of temperature, independent of increase in temperature, increase in temperature. The length of aluminum rod aluminum rod is, now here are given the options, but before that we are given alpha copper. This is given alpha copper equal to 1.7 into 10 raised to power minus 5 K minus 1, and alpha aluminum. This is 2.2 10 raised to the power minus 5 K minus 1. The option first is 6.8 centimeter. Option second is 113.9 centimeter. Third option is 88 centimeter. And fourth option is 68 centimeter. Now solution to this question. What is given that the increase in length independent of increase of temperature, and we know that whenever temperature increase of the conducting rod, its length increases, no doubt. But what is given in question that we have to solve the question like this one. So we know the increase in length delta L is equal to L naught alpha into delta T. So this delta L upon delta T is equal to L naught into alpha. We have to use this one. This increase in length with temperature is independent. So we have to take this to be same for both the rods, copper and aluminum. So what do we do? That delta L upon delta T for copper equal to delta L upon delta T for aluminum. This you make equal. Now then we have this L naught. So this is now your L naught copper into alpha copper is equal to L naught aluminum into alpha aluminum. This is the simple formula. You have to find the length of aluminum rod. So L naught aluminum equal to L naught copper alpha copper upon now this alpha aluminum. So this is what L naught copper is given to you. This is not 88 centimeter. 88. Alpha copper is given to you. Alpha copper is 1.7 into 10 raised to the power minus 5 upon, this is given to you 2.2 10 raised to the power minus 5. Just to solve, this will cancel, point will cancel, this will cancel by 4. So this 4 into 17, this is 68. So initial length of the aluminum is 68. So our answer must be what? Now see the choice 68 centimeter. This is now fourth. So fourth option is correct. Now we come to question number 14. Unit of thermal conductivity. Unit of thermal conductivity is, now option First is your joule meter per Kelvin. Joule meter per Kelvin. Second, joule per meter per Kelvin. Third, watt meter per Kelvin. And fourth, watt meter minus 1 K minus 1. Now solution to this question. You must know the formula of thermal conductivity. Delta Q is equal to Ka delta theta upon delta x into T. Now this area, this is now distance between the two surfaces of temperature difference delta theta. So this is now your K minus 1, K minus 1 is coming in all. This is now your meter minus 1 here. You have to find the K. So this is a meter minus 1 and this is your joule. So joule into joule meter minus 1. Joule meter minus 1 this is given. But here this T is left. So joule per second. This is now watt. So watt per meter per Kelvin. So K is equal to delta Q upon T into delta X upon A delta theta. Now you can find it easily. This is now your watt. This is your meter minus. This is now your K minus. This is what the units. So now right option is this one, fourth. So our answer is fourth. This is not fourth. Now question number 15. Question number 15. When a block of mass M, when a block of mass M is suspended by a long suspended by a long wire of length L. Wire of length L. The length of wire becomes the length of wire becomes L plus L. L plus L. The elastic potential energy. The elastic potential energy stored in extended wire is option MGL. Second, this is mg capital L. Third, half mgl. And fourth, half mgl. mg. Now solution. Potential energy is equal to the work done in extending the wire to a length L, by a length L. So stored energy U is equal to work done. So this is equal to your 1 by 2. Now force mg, and change in length is small l. This is small l. This is now your small l. So this is 1 by 2 mgl. This is also taught to you in case in the chapter of elasticity. That so much energy is required to extend the length of the wire by so much, and then this energy is stored in the new length or the increased length of the wire. So our answer is, this is now mgl, this is now third one. Third answer. And now question number 16. Your question number 16 is a disc of radius 2 meter. A disc of radius 2 meter and mass 100 kilogram. Mass 100 kilogram. Rolls on a horizontal surface. Rolls on a horizontal surface. No, floor. Horizontal floor. Floor. Its center of mass and speed. Its center of mass has speed of 20 centimeter per second. How much work is needed? How much work is needed to stop it? To stop it. Now your choices are given: first 3 joule, second 30 kilojoule, third 2 joule, fourth 1 joule. These are the options. Now here we have a disc, and this is rolling on the surface, horizontal surface. So it has both kind of motions, the rotational and translational. So the total energy, what is the total energy that will be required to stop this moving disc? So solution is energy is equal to half mv square into 1 plus k square upon r square. This is the direct formula, the total energy. So this energy E equal to half m given to you 100, v is given to you 20 centimeter. 20 centimeter means 0.2 meter. 0.2. 1 plus, for disk k square upon r square equal to 1 by 2. So this will cancel 50. This point will cancel by this one. This is now your 4 5 the 20. And this one point is here. And this is now your 3 by 2. 2 and 2 cancel. So we are left to get 3 joule. 3 joule. Here is the first answer. Choices. So now we have the first choice. Now question number 17. In an experiment, the percentage of error occurred in measurement of physical quantities A, B and C and D are your 1%, 2%, 3% and 4% respectively. Then the maximum percentage, percentage of error in the measurement of X, where X equal to, this is A square B raised to power half upon C raised to power half into D raised to power 3. And now your bill B. Now options. First option, your 3 upon 13%, B, your 10%, 16%. Third, minus 10%. Fourth, your 10%. This is given. And now you will find the maximum error. If you have studied the chapter of measurement and errors, then you can solve this question directly. The solution to this question, X equal to A square B raised to power half upon C raised to power half into D raised to power 3. This is so much is given to here. So now this delta X upon X percent is equal to 2 delta A upon A percent plus 1 by 2 delta B upon B percent plus 1 by 2 delta C upon C percent plus 3 delta D upon D percent. This is the, you have to find the maximum error, so you eliminate all the negative signs and take them all positive, and whatever the indices are given, they will be multiplied by this error. This is now 2, this error is 1%. Now this is 1 by 2, this is now your 2% plus 3 into this is now your 1 by 2%. The delta C upon C, this is your 3%. 1 by 2. C is 3%. C is 1 by 2, 1 by 2 delta C upon C 3 plus 3 into this is now your 4%. So delta C, this is your what? C is given to be 1 by 3, not 1 by 2. This is 1 by 3. This is 1 by 3. So this is 1 by 3. So 2 and 2 cancel, 3 and 3 cancel. So this is now 2% plus 1% plus 1% plus 12%. This total is your 16%. So our right answer is what? This is the B. Sorry, this is now second 16%. Maximum error it will be 16%. And now question number 18. A cylinder of mass 2 kg. 18. Which color of length? Light. 18. A body weighs, weighs 200 newtons on the surface of Earth. Surface of Earth. How much will it weigh? How much will it weigh? Halfway down. Halfway down to the center of Earth. Center of Earth. Now your option is first 150 Newton, second is 200 Newton, and third is 250 Newton, and fourth is 100 Newton. These are the given choices. A body weighs, I have done the such type of question in NEET 2020. Mg is given to you 200. Now this is the question like this. This is the earth. This is now so much halfway. Now this is what we have to consider. How much will it weigh halfway down? Halfway down. So this is now radius r is so much. Halfway, this is now r by 2. So distance is given to you r by 2. So now weight at this point. At this point, W dash equal to mg dash, and mg dash is equal to d into 1 minus d upon, this is the formula, the change in gravitational acceleration in the depth of the earth or inside the earth. This mg is given to you 200 Newton. This is 1 minus d is given to you r by 2. This is now r by 2 given to you. This will cancel. This is now 200 into 1 by 2. So this will be 100. Fourth. Now we have the, so our answer is fourth. 18 and the question number 19. Which color of light? Which color of light has the longest wavelength? Now option is, first is your red, second is blue, third is green, fourth is violet. These are the options. Now you can know about the Vibgyor. Vibgyor. Now when we go in this way, the lambda increase, and when we go in this way, lambda decrease. It means that red has the longest wavelength and violet has the minimum wavelength. So right option is first. Here we have answer is your first, red. It is the maximum wavelength. And now your question number 20. A cylinder of mass 2 kg and radius 4 centimeter. Is rotating around its own axis. Is rotating about its own axis. At the rate of 3 RPM. 3 RPM. The torque required to stop. The torque required to stop after 2 pi revolutions. Is first is 2 into 10 raised to the power minus 6 Newton meter. Second option is 2 10 raised to the power minus 3 Newton meter. Third option is 12 into 10 raised to the power minus 4 Newton meter, and fourth is your 2 into 10 raised to the power 6 Newton meter. Now the solution. Now you have to solve this equation by two methods. Torque equal to I into alpha. I the moment of inertia. This is given the cylinder. So I mi. This I is equal to 1 by 2 mr square. This is now given to here. And then we have to find the value of alpha, the angular acceleration. The angular acceleration, for that, what is given to us, that the cylinder is rotating with the speed of so much rpm. So omega naught equal to 2 pi n. This is not 2 pi n is equal to your 3 rpm, rotation per minute. Convert it into minute to second. This is now your 6, so this is now your 10. So this is now your pi upon 10. So much radian per second. This is what the initial speed. Now then we want to stop it. So this is now 0, and angular acceleration, this is to find out. And this is given the 2 pi revolutions. This is the displacement, angular displacement. Theta is equal to 2 pi revolution. And we know that this theta is always in radians, because this is the angle. This is given in revolution. This is now your 2 pi, and in one revolution the displacement is 2 pi radian. So this is now your 2 pi, and this is now your radian. So this is now your 4 pi square radian. So much is the theta. And now we have to find out the alpha. So now we apply the equation of motion for rotational motion. This omega square equal to omega naught square plus 2 alpha theta. This is now your 0. This is omega naught square plus 2 alpha theta. Therefore, alpha equal to minus omega naught square upon 2 theta. This is given. Since we have to stop the rotating cylinder, so the acceleration will be negative. Omega naught square is now pi upon 10. Pi upon 10 into pi upon 10 upon 2 theta. This is now your 4 pi square. 4 pi square. So how to solve this? Some of the questions students do it in somewhat in a way that is not right one. So this will be your pi square upon 10, this is now your 100 into, this is now 2 pi 8 and this is now your pi square. So you write down like this. Now this pi square term will cancel. This is now 1 upon 800. So much is radian per second square. This is the angular acceleration. Therefore, torque equal to I into alpha. I 1 by 2 mr square into alpha. 1 by 2, this is mass 2 kg and radius is given 4 centimeter. So this is now 4 into 10 raised to the power minus 2 whole square. Now this is your 1 upon 800 alpha 800. 2 and 2 cancel. This is now your 16 into 10 raised to the power minus 4 upon 800. So now you can cancel it. 8, 16, now 10 raised to the power minus 6. So this is now 2 into 10 raised to the power minus 6. So we need so much torque. So our this the answer is to this one is where is 2 to the first it's not first. So our answer is first. 2 into 10 raised to the power minus 6 Newton. So much torque is required. There is one more way by which we can find the torque. Alternative is what? Since the body is rotating, it means that it has the rotational kinetic energy. So rotational kinetic energy is equal to half I omega square. And now this work done is equal to torque into theta is equal to half I omega square. So by this method you can also find the answer. This torque equal to half I omega square upon theta. Now everything is given half I 1 by 2 mr square into omega square upon theta. So this is now your 1 by 4 m. Mass is given to you 2 kg. R is 4 centimeter. Omega this is omega naught. Omega naught is given to pi upon 10. So this is your pi square. Pi upon 10 whole square. Upon theta. Theta is given to you this one. 4 pi square. This is now your 4 pi square. So now this you find the all values and then calculate. This will cancel by 2. 1 by 2 into 4 into this is 16. 4 10 raised to the power minus 4 into pi square upon 100 upon this is now your 4 pi square. So this pi square will cancel. 4 to 8, 8 to 16 and 8 to 16. So this is now your 2 into 10 raised to the power minus 4 and this is upon 100. So this is minus 6. So much Newton meter. Again our option is first. First option is right. So one question may be solved by more than one method. So this is what the solution of the 10 questions after the 10th question that I told you earlier before this lecture. So now I will take the next remaining next 21 to 30 questions that will be in the next lecture. So So you all like, share and subscribe this video. Also watch the video completely. Only then you can get the benefit, otherwise no benefit. So thanks to all of you.